let's briefly review where we're at. So we've just been reviewing a bit about basic physics, and the first fact that we reviewed is that the resultant forces and moments are zero for static equilibrium. So the static equilibrium requirements are that the resultant force R here is equal to zero, and that the resultant moment is equal to zero. And the resultant moment can be taken about any point that's convenient. So say the origin of the coordinate system. So you have the body, you have a set of forces, you have the position vectors to the forces. If you add up all the forces, that gives you the resultant. And if you add up the cross products of the position vectors to the forces with the forces, add those up, that gives you the resultant moment. And those both have to be equal to zero for a rigid body to be in a state of static equilibrium. So that was sort of the first thing that's important to remember about elementary physics. The other thing that we've exploited in the examples that we've done so far is that if the forces have to be concurrent through a given point, say the origin, then the resultant moment is zero a priori, and you don't ever have to worry about checking for moment equilibrium. You only have to worry about force equilibrium. To be able to do force equilibrium, we had a couple of special tools. There was the graphical tool, say the force polygon, which says that if you have a set of forces, you can line them up head to tail, and they have to make a closed polygon for the system to be in equilibrium. So you can use then that geometric diagram to help you determine the unknowns in the problem. If you happen to have only three forces in your system, then your force polygon is a triangle. Let's say A angle alpha, B angle beta, C angle gamma. Then you can use the law of sines, which says that A over sine alpha is equal to B over sine beta, which is equal to C over sine gamma. So that's a useful bit of geometry for solving problems. Also, you can have the law of cosines. So if you have the a triangle, then you also have the result that C squared is equal to A squared plus B squared minus 2AB cosine of gamma. So that's the law of cosines, which is also useful to know. Likewise, for solving problems, you can just simply add the components of the vectors that set up your resultant and set each one, the x, the y, and the z equal to 0. And then we also had, in the examples that we looked at, this unit vector construction. So if I know 2 points, let's say A and B, and I want to know the expression for the unit vector that goes from A to B, well, I can form that using the vector itself that goes from A to B, and the unit vector EAB is RAB divided by the length or the norm of RAB. So that's also helpful in solving problems.